Chapter 2 is going to deal with polynomial and rational functions. So a lot of what we'll deal with will be factoring, but the main part, at least for the first part today, will deal with complex numbers. Remember from Algebra 2 that whenever we had an imaginary unit, that whenever we had the square root of -1, that was the same thing as just I. Whenever we had I squared, then that took the square root away and we turned it into a real number. So I squared became a real number of -1. Whenever we put anything, so like equality of complex numbers, basically if everything is going to be equal, real numbers here, okay, we can only look at real, we can compare real with real and imaginary with imaginary. Okay, we can't combine real and imaginary numbers together. We have to leave them separate, and remember that real numbers always have to go first in terms of standard form. Operations, we treat anything with imaginary numbers the same as we would if it was an x or a y or a q or whatever variable. Okay, biggest thing that you have to make sure that you do, especially with adding and subtracting, because I know that I'll get students that won't pay attention that there is a sign in between the parentheses. Okay, pay attention. If there's a sign in between there, then you're going to either add or subtract. It's whenever but the majority of the time what will happen here is students will multiply. Okay, if there is space between and you have a sign between your two parentheses, then you're going to either add or subtract. Trust me, I know that it's going to happen because I will see it too many times that students will just want to multiply because they see that things are in a parenthesis and so forth. Basically, what you want to do here is, and I'm not a big fan of putting your real numbers in a parenthesis together and your imaginary numbers together. Just add the reals with the reals and the imaginary with the imaginary. Okay, you don't have to group it this way or this way. You can just basically find which ones are real, which ones are imaginary, and combine them. So, like as far as the examples are concerned, like if I have 5 minus 11i, I'm not going to group the 5 and the 7 together. I'm just going to look, okay, it's addition. I may write it out again just so I have 5 minus 11i plus 7 plus 4i. But I'm just going to combine my real numbers together, so 5 plus 7 is 12. And then I'm going to look at my imaginary numbers and have a -11 plus 4, so it's going to be a negative or minus 7i. Okay, remember, real number goes first, imaginary number goes second. You treat it like any other variable. Okay, it's only whenever we have I squared that we're going to change its actual value. Same way with subtraction. I'm just going to rewrite the first part, and the reason why I rewrite it is really just so I can make sure that I distribute that negative. So I have minus 12 plus I. Then again, real number with real number. So -10. Imaginary with imaginary, so 6 plus 1 is just going to be plus 7i. Biggest thing you've got to make sure that right here with the subtraction is that you change the sign of everything. So the sign is going to change your 12 and it's going to change your sign of your -i. Okay, don't let silly mistakes happen because there's no need. Just take your time, pay attention to what's going on. Multiplying is the same way. That doesn't really change. We treat it just like anything else. The only thing we've got to pay attention to is right here. that if you get an I squared, we're going to turn that into a negative 1. Okay, it's just going to turn everything into a negative 1. So if I have 7i times 2, that's just going to be 14i. 7i times negative 9i is going to be a negative 63i squared. Now, again, don't leave it like this. We are not finished. Because what is I squared? Negative 1. So it's really negative 63 times negative 1. So what is negative 63 times negative 1? A positive 63. Okay? Now, we're not finished here. Okay? Because if I have 14i and I bring it around, standard form, the real number goes in front. So I'm just going to switch my order. 63 plus 14i. Now I'm finished. Okay? All that I squared is really going to do is just change that negative 63 into a positive 63 is the only thing that's going to happen. Same way if you have two binomials and you're still multiplying, okay? It's ones like 1 and 2. It's like problems like on number 4. This is why students always multiply, because they see it in parentheses and they don't pay attention that there is a sign in between the two parentheses. Okay? There will be plenty of space between your parentheses or between your binomials to tell if you need to add, subtract, whatever. Okay? If they're right beside each other, yes. If there's no sign, then just simply multiply and go 5 times 6 and get 30. Go 5 times negative 7 and get negative 7i, so negative 35i. Then add 24i, and then multiply to get negative 28i squared. So again, for me, I would probably do two things at once. I would combine my i's and I would change my negative 28i into a real number. So whenever I do that, I'll have 30 minus 11i. That's just going to change it to a positive 28. Now combine my like terms, which are my two real numbers. I'm going to write it up here so you can see it, and get 58 minus 11i. Now, with division, it's really just a matter of you are multiplying by the complex conjugate. All you're doing is you're just multiplying. Okay? You're used to seeing if we have, my fault. If we just look at it in terms of real numbers, if we have x minus 4 times x plus 4, okay, those two are what's called conjugates of each other. What's the only thing that changed between the two? Did the variable change? No. Did the constant change? No. What's the only thing that did change? So before, whenever we had like x minus 4 and x plus 4, if we would actually multiply these two together, we would get x squared, and then we'd have plus 4x minus 4x, and then a minus 16. Well, what was going to happen right here in the middle? It was going to go away, right? Positive 4x and a negative 4x, everything was just going to cancel, and we were just going to be left with the first and the last getting multiplied. That's really what we want to happen with a complex conjugate. We want the middle to go away. Okay, so if we have a plus bi and we need to, or whatever that value is, we need to multiply it by its conjugate. We don't change every sign, we just change the sign in front of the imaginary number. So like if we have 7 plus 4i over 2 minus 5i, we need to multiply both the top and the bottom by its conjugate. because we can't have an imaginary number in the denominator, because an imaginary number is just a radical. Well, we can't have a radical in the denominator, so it's the same thing. Okay, so what's going to happen here is that we're going to multiply both the top and the bottom by 2 plus 5i. Okay, we only care really about the bottom side. We only care about the denominator. We don't care so much about the top as we do the bottom. Okay, so that's what's going to dictate what we multiply the top and the bottom by. So I'm just going to go 2 plus 5i, because I'm not changing its value, I'm just changing how it looks. So if I change how it looks, I'm really just multiplying it by 1, and then I just turn it into a multiplication problem. Okay, hopefully the top is the biggest thing that really gets changed. I mean, you can write it however you want. It's really up to you. If you want to have 7 plus 4i times 2 plus 5i, you can rewrite it again. You can do the same thing on the bottom. This is really all we're doing. And then going 2 plus 5i, and really just turning it into two multiplication problems is all we're going to do. So then the top side, 7 and 2 is going to give me 14. 7 and the 5i is going to give me plus 35i. 4 and 2 is going to be plus 8i. And then 4i and 5i is going to give me a positive 20i squared. Now, it's completely up to you what you want to do. If you just want to focus on the top first and then worry about the bottom, do it. Okay? I have no issue in that. That's probably not a bad idea, because what's the positive 20i going to turn into? Negative 20. So really, I'm just going to have 14 minus 20 on the top side, so that's going to be negative 6. And then I'm going to have 35i plus 8i. I'm going to combine my imaginary numbers and have 43i. Now, the bottom is completely up to you as far as how much or how little you want to do this. Kate, do you have a question? No? If you want to multiply every single part and go 2 and 2, 2 and 5i, that's fine. Okay? But just know, if I do that, 2 and 2 obviously is 4. 2 and 5i is a positive 10i. Remember, the whole point of this is to get the middle part to go away. So whenever I go negative 5 and positive 5i, I'm going to have negative 25i squared. So again, what's going to happen right here in the middle? It's just going to go away, right? Because one's positive and one's negative. What's the negative 25i squared going to turn into? Positive 25. So really I just have 4 plus 25 on the bottom and have 29. Once I get to where I have a real number on the bottom side in my denominator spot, everything's in good shape. Okay, that's what I want to happen. Okay, I have no issue in you basically taking 2 and 2, okay, multiplying 2 times 2, we got the 4, taking negative 5 and positive 5 and getting 25 and just changing the sign, because that's all we're going to do anyway. Okay. Now, roots of negative numbers, really, you treat anything just the same way as you would anything with a squared or a root. if it's negative, or if it has an even root, rather. So like a square root, if it has a negative, you're just going to pull the I out. Okay, this probably should be the first thing that we talk about. But you treat everything the same way. So if I'm going to factor out, that's not what I wanted to do. If I want to factor out here, I'm going to factor out the I, so the negative 1. I'm going to factor out a 9, and I'm going to factor out a 3. Okay. So then, that's I, that's 3, that's still the square root of 3. So I have 3I times the square root of 3. I'm going to do the same thing over here with the 48. And I'm going to have a negative 1. I'm going to have a 16. And I'm going to have a square root of 3. So I'm going to have 4I times the square root of 3. Now we can just add everything together. Okay, 3I plus 4I, 7I times the square root of 3. Okay, remember, you can only combine if the square roots are the same. And it's going to work the same way if you have, like on 8, it's going to work the same way. If you need to write it out twice, and you need to have negative 2 plus square root of negative 3 times 2 plus the square root of negative 3, do that. Okay? It's squared. If you don't want to shortcut it, just FOIL it or multiply it. It's completely up to you on how you kind of run this out. Okay, I can multiply. Oh, that's a negative 2, my fault. So 4, that's going to be negative 2 times the square root of negative 3. Same thing, minus 2 times square root of negative 3. And then what's going to happen? What's the square root of 3? Or what's the square root of negative 3 times the square root of negative 3? What's going to happen to the square roots? They're just going to drop off, right? So then 4 minus 3 is 1. So I have 1 minus 4 times the square root of negative 3. Now, I'm not finished because what can I not have underneath the radical? Can't have a negative. So what's going to happen with that negative? What's this negative right here going to do? Where's it going to go? It's going to come out and be an I. So I'm just going to have 1 minus 4I times the square root of 3. The biggest thing I can tell you is taking your time with your radicals or with the I and not getting in too big of a hurry and making a silly mistake. Same way on 9. 9, you really the only thing you have to focus on is going to be right back here with that square root of 12 or negative 12. Okay. Once you simplify that, then that's just going to be, it's going to have an I. If we would simplify the square root of 12, that's just the square root of 4 and the square root of 3. So I'm going to have 2I times the square root of 3. So if I have negative 14 plus 2I times the square root of 3 all over 4. Now I'm not finished here because what can I do with everything? What is every part divisible by? 2. Okay, so that's going to go to a 7, that's going to go to a 1, that's going to go to a 2, and we're going to clean everything up and have negative 7 plus I times the square root of 3 all over 2. For those of you that do not, or that have a calculator with that capability, most of the time I think they will not, it'll turn it into an I, but it'll still give you a decimal, so you'll still need to know that it's, remember, A is equal to 1, B is equal to -2, and then C is equal to +2. Remember, quadratic formula is the opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. Plug and chug, especially with, so the opposite of B is going to be a +2, plus or minus. Make sure that, like with the B squared, if it's negative, and I don't know, I had some, whenever we did this in Algebra 2, that put it in a parenthesis, making sure, because it's going to make that value positive all the time. -4 times 1 times 2 all over 2A, which is just going to be 2. So 2 plus or minus, inside the radical is going to be a -4 all over 2. So I'm going to have 2 plus or minus 2I over 2. What can I do with all my values? It's just going to turn into 1 plus or minus I, because that's going to reduce to 1, that's going to reduce to 1, and that's going to reduce to 1. But the biggest thing here is making sure that, so like if I have 4 minus 8, make sure it's not a -4. Make sure we put a parenthesis around that B squared all the time. Okay, that was a mistake that, like I said, some of my Algebra 2 kids had when we talked about this.